In this chapter, we will discuss philosophical foundations of artificial intelligence. So far, we've seen that AI is taking tabular data and then classifying it or building regression models and things like that. Philosophers have a different perspective about AI. Philosophers think, is it possible for machines to act intelligently in the way that people do? And if these machines in fact acted intelligently, would they have real conscious minds? That's what philosophers are concerned about. While we, computer scientists and engineers, are thinking about building models that actually solve some problems in real world, philosophers are more interested to ask if machines that act intelligently have real conscious minds. Now, with that perspective, philosophers think that AI can come in two forms, either as a weak AI or as a strong AI. So, what they think is that if the machines can act as if they were intelligent, then that kind of AI is actually weak AI. And thus, they argue that many of the AI that we do is currently a weak AI. So, all the AI that we do is actually, we're not building intelligent agents, but instead, we are building agents that act as if they were intelligent. Now, what philosophers think is that AI would be strong if we could build machines that not just act intelligent, or those machines that we build which act intelligent are actually thinking, not just simulating thinking. Now, this is very important, the word simulating here. So, philosophers argue that all the machines that we build or all the agents that we build so far are actually simulating thinking, but actually not doing the thinking as the way we humans do. Now, let's see what AI researchers think. Now, AI researchers have a different view for this. They take the weak AI hypothesis for granted. That is, they think that if we can do weak AI, then that's it. We don't even need to worry about a strong AI. AI researchers don't care about the strong AI hypothesis. That is, whether we are actually thinking or not, if we can do intelligent things, then that's good enough. That is, as long as the programs that we build work, and AI researchers don't care whether you call it a simulation or a real intelligence. Now, let's talk a little bit about the weak AI. That is the AI in which we build machines that act intelligent, but they may not necessarily be actually thinking the way we humans think. Now, to discuss this, we have to go back into the history when AI was founded. AI was founded on the following assumption. Now, this was around 1955. Every aspect of learning or other feature of intelligence can be so precisely described that a machine can be made to simulate it. The designers of AI, or the people who introduced AI, thought that the way in which we do the learning, or all of the features of intelligence, our intelligence features, can be described so well that a machine can be made to simulate it so that it demonstrates such an intelligence. Now, for engineers, the definition of AI works well because the problem is finding a good agent, and as long as we demonstrate some form of intelligence, then we can continue to build agents that make an impact in the society. Whereas philosophers have a different take. They are interested in the problem of comparing the two architectures, that is, humans and machines. So if you have a human here and a machine here, we are more interested in, can this machine achieve the things that people can do? Whereas philosophers are thinking, well, let's not look at the results. Let's look at how they are thinking. And what are the architectures of these two? So humans are actually thinking, making decisions inside, and the way they are doing. Are machines doing the same? That's the kind of questions that they would like to ask. And they pose the question of weak AI, not in terms of maximizing expected utility, where you build the AI to make it do something useful, but rather they pose the question as, can machines think? They're more interested in the insides of the system that we build than the outcome of the system or the agents that we build. Now, this debate went on for a long time, and Dijkstra in 1984 presented his view in this way. He said, the question of whether machines can think is, is about as relevant as the question of whether submarines can swim. So he said, if submarines can swim, then we should say that machines can think. If we say that submarines can't swim, then we should say that machines can't think. Now let's dig deeper into what he's trying to say here. Let's take a look at the first example, example one. Now let's try to look at the dictionary definition of swimming. So swimming, in the dictionary meaning, what it means is to move through water by the means of limbs, fins, or tail. This is very important. So in the dictionary, we define swimming as moving in the water with the help of limbs, fins, or tail. Now, most people agree that submarines, being limbless, because submarines don't have limbs, right? They cannot swim. So far, so good. So let's look at another example. Next example, let's look at the dictionary definition of fly. So in dictionary, fly means to move through the air by the means of wings or wing-like parts. This is important. So in the dictionary, for flying, however, the dictionary says that if you have wings, actual wings like birds do, or if you have wings like parts, then we consider that that object is flying. And most people agree that airplanes, which have wing-like parts, they can fly. So very interesting that just the way dolphins and fishes swim, we built submarines and we think that submarines cannot swim, even though the submarine moves in the water. But we've also built airplanes and we think that airplanes can fly. This is really tricky. So these two opposite examples are not concerned with the design or capabilities of airplanes and submarines. Rather, they are about the uses of the words in English. That is, these two words, swim and fly, are more concerned with how we use the word rather than what submarines can do, what airplanes can do, and so on. Because here you could take a side. You could say that well, these two should be consistent. That is, swimming and flying definitions should be consistent, and we should say that submarines can also swim. Or you could take the other side and say, well, since we say that submarines cannot swim, we should also say that airplanes cannot fly. So then coming to the question of can machines really think, that is what the question that philosophers have been asking. To answer this, we have to define what is thinking. Now, importantly, when we define thinking, we want to answer, does thinking require a brain or does it require brain-like parts? Just the way we said wing-like parts, do we define thinking as something that can be done necessarily with a brain? Or if we have brain-like parts and if it's doing something, we also consider that thinking. Now, according to the dictionary definition of thinking, you can see that thinking says, the definition of thinking is direct one's mind towards someone or something, or use one's mind actively to form connected ideas. So here, this definition of thinking, interestingly, assumes that only people can think, that only having a mind that people have can one think. So what Dijkstra pointed out was that the question, can machine think, is ill-defined because if you define thinking as something that only human mind can do, asking can machines think is stupid because machines can never think. If we define that only human mind can think, then only human mind can think. Machines can never think. So we have to change the definition of thinking if we want to appropriately pose this question about can machines think. Interestingly, now let's switch to the topic of strong AI, that is the topic where we ask, can machines really think the way we humans do? And many philosophers, interestingly, claim that, say we build a machine that passes the Turing test, right? Many philosophers claim, probably because they fear that someday, very quickly, we will pass the Turing test. They say that a machine that passes Turing test still would not actually be thinking, but would only be a simulation of thinking. Now, Turing test is really difficult to pass, right? So it's a test where a human cannot distinguish between an AI and a person. So philosophers are really making it difficult for AI to claim that artificial intelligence is possible. So basically, what they're asking is, can a machine be conscious? Can a machine be aware of its own mental states and actions? That's what they are trying to say. So only if we can do that, then they consider that the strong AI definition has been fulfilled and strong AI has been achieved. Now, to this question, here's what Turing had to say. So Turing does not claim that machines can, in fact, be conscious, right? So because even if you pass his test, the machine may not be consciously thinking about things. It may just be pretending to be humans, or like, fooling humans. So then he goes on to say the question is just ill-defined as asking, can machines think? So this question of can machines be conscious is as ill-defined as can machines think. Here's why. He says that why should we insist on a higher standard for machines than we do for humans? Now, this is a little bit interesting here because he says, in an ordinary life, we never have any direct evidence about the internal mental states of other human beings. So, say two people are talking, right? And let's say the first person, P1, says you something, then do you go on to ask and check, were you actually thinking, and cross question the other person and maybe argue that you are not actually thinking or you are thinking, and do so on? So if we do not impose such standards on people, why should we pose such a standard for machines, right? He said, instead of arguing continually over this point, it is usual to have a polite conversation that everyone thinks, just the way we do in everyday life. So we assume that everyone is thinking, everyone is doing their part, and then we move on. So Turing's response was a little bit funny, but this is how he got away with arguing with philosophers on this topic. So we can easily imagine some future time in which conversation with the machines are commonplace. That is, you may be sitting side by side with a machine and having a conversation with a machine. It becomes customary to make no linguistic distinction between real and artificial thinking. So this is a relatively heavy question where tomorrow, say you are sitting somewhere and you have a machine sitting beside you and you're having a conversation with this machine, then someday there may be a day where it may not be different for you to talk to a person than to a machine. Do you agree? This is something to really think about uh, because there may be times when people actually in future start having fun and enjoy chatting with a machine as much as they do with another human being. In this context of strong AI, that is our discussion about can machines really think, the history of artificial urea is something that's interesting to know. Let's talk about artificial urea. Organic and inorganic chemistry were essentially two disjoint enterprises in chemistry in the 1800s, and many thought that no process could exist that would convert inorganic chemicals to organic material. So that's what chemists believed. In 1848, Frederick Euler synthesized artificial urea for the first time. And once the synthesis was accomplished, once he found out artificial urea, which had same properties as organic urea, chemists agreed that artificial urea was urea because it had all the right physical properties. For a long time, people didn't agree. People didn't think that you could create organic material from inorganic chemicals. And those who had argued that you cannot do this, you cannot convert inorganic chemicals to organic material, um, that those who argued that an intrinsic property possessed by an organic material cannot be possessed by an inorganic material, those who made this argument were put in a very difficult situation where they faced with the impossibility of devising any test that could reveal the supposed deficiency of artificial urea. So basically, we had organic urea, and then this guy creates an artificial urea, and people are thinking, no, artificial urea is never equal to organic urea. You cannot devise anything artificial that has the properties of organic urea. But then once this guy did, people had to accept because they couldn't devise any test that would separate organic urea from artificial urea. Now, many people believe that for thinking, artificial intelligence has not reached the 1848 yet. And there are those who believe that thinking, no matter how impressive, will never be real. That is, will never have 1848 for artificial thinking. Now, in this context of a strong AI, philosophers have something very interesting to say. Particularly, philosopher John Searle had to say this: no one supposes that a computer simulation of a storm will leave us wait. So if there is a storm in your laptop, then that doesn't make us wait, right? Why on earth would anyone in his right mind suppose a computer simulation of mental process actually had mental processes? So if a computer is thinking something inside the computer, why should we think that it actually has mental processes? Makes sense, right? Just the way if a computer gets wet inside in the software, we don't, it doesn't make us wet. Now, the authors of the book have to say this: while it is easy to agree that computer simulations of storms do not make us wet, but it is not clear how to carry this analogy over to computer simulations of mental processes. So something like a wind, storm, getting wet, water are physical processes. So if you simulate physical processes in a computer, of course they don't carry over to the real world. But mental processes are not physical. So a Hollywood simulation of a storm using sprinkles and wind machines does not make the actors wait, right? Clearly, most people are comfortable saying that a computer simulation of Edison is Edison and of chess is chess. In other words, what the authors argue is if a computer in calculating finds out that 2 plus 2 equals 4, does that mean that in real world 2 plus 2 is not equals to 4? Of course not. Because mental processes are same whether we carry it inside a computer or outside the computer. That's the argument that the authors have to make to disagree with philosopher John Searle. Now, the authors further argue that we typically speak of an implementation of addition or chase, not a simulation. So he thinks that mental processes are implementations, not simulations. Now, here's a question for us to think. What do we think? What do you think? Are mental processes more like storms, or are they more like addition? That is, do you think that when a computer is thinking, is it a simulation or is it an implementation? If you agree it's an implementation, you have to agree that our mind is also one of the implementations of thinking.